Welcome to Kippy C Math! Today, we're going to use addition properties to complete equations. Now, what are addition properties? They are rules about sets of numbers that are true no matter where you go in the world. That's one of the coolest things about math, is that it describes relationships and patterns we see in numbers that are true everywhere. John Urschel, who was a player in the NFL and is a modern day mathematician, talks about how these truths are one of the things that made him so interested in learning mathematics. He is a really cool guy. He played on the Baltimore Ravens team for 3 years. He played a lot. He was in several of their playoff games against the New England Patriots. And the whole time he was doing that, he was also studying math in college. And now he's working on getting his PhD. He even has a math theorem named after him, which is kind of like a math truth that's discovered based on other math truths. So you can learn about those in college. Some people might think that if you're really interested in sports, then you can't be interested in math. But that's not true. You can have lots of different interests. And we can listen to John Urschel say a few words about that.
You like math and sports? I would really encourage you to do math and sports. I think these are two amazing things. First of all, as far as math goes, I feel like I'm preaching to the choir, but math is it's such a fundamental thing in our world. This is truly the language that we use to explain the world around us, and it's a very fundamental thing.
So let's get into some of our learning for today. Rules in math are sometimes called properties. And so we are going to talk about two addition properties. The properties are actually really simple and really basic. But when you learn them, then you can start to use them to describe more complicated things later on. Let's start with the commutative property. In this plate, I have some apples and some oranges. I could count them up like this: 1, 2, 3, 4, 5. Apples, then oranges. That would be like 3 apples and 2 oranges makes 5 pieces of fruit. Or I could count them up oranges first, right? 1, 2, 3, 4, 5. The equation for that would be 2 plus 3 equals 5. And of course we still got 5, right? Because we didn't change the fruit at all. We just counted it a different way. We just put it together a different way. We just added it a different way. Well, here's what's really cool. Now that we know that the equal sign means the same as, we can put these to equal to each other. We can say 3 plus 2 is the same as 2 plus 3. Basically, if you change the order, you still get the same answer. And you also get to write really cool true equations like that one. This is called the commutative property, or sometimes people call it the turnaround rule, because it's like the addends got turned around. Your turn. If we are turning around the addends and getting the same answer, what would I put in these blanks? Go ahead and type the numbers in the blanks. We get 3 and 6 because we just turned around the numbers. The other property is called the zero property. Notice in this bowl, I don't have any oranges. There are 0 oranges. Let's count them up. 1, 2, 3. And that's it, right? There were 3 apples. And when we add 0 oranges, of course we get 3. We represent it like this. Whenever we add nothing to a number, it stays being that same number. And of course, now that we know that the equal sign means is the same as, we could also write it like that. 3 is the same as 3 plus 0. Because adding 0 means nothing happens. And if we think about this like a seesaw, it basically means we have 3 apples on each side of the seesaw. That's a true equation. So that's the zero property. Your turn. The zero property is so easy, it almost seems silly. You go ahead and fill in what number goes in the blank. Right, it's a 6. And of course, we could have written 6 plus 0 plus 0 plus 0 plus 0 plus 0. And this side of my seesaw and this side of my seesaw would still be the same as each other. And now it's time for our special guest.
Hi.
Hi, how are you?
I'm great. How are you?
Good. I'm Mrs. Taylor. It's nice to see you.
Oh, it's great to see you. Thank you for talking to us today.
Yeah, thanks for having me.
We learned that the equal sign means is the same as, and we were wondering if you could tell us now that we have this like blank in this equation, how we could fill in the blank.
Oh, sure. So what I would do is I'd look at both sides of the equation and I'd try to figure out if there was something the same. So in this one, I see that the 3 is the same. So let me circle the 3. And then on the other side of the equation, the 3 is the same over there.
Got
And
it.
then all I have to do is match up the rest.
Okay.
So I have to put a 2 on this other side so that the equation matches. So that one was really easy. Again, I started with looking for the things that were the same, and then I matched up the things on the other side.
Perfect. Okay. And what about 4 equals 0 plus 4? I don't see anything the same.
Yeah, you're right. You are right. So in this instance, we would try to make it the same. So we don't have a 4 over here. So I'm going to put a 4 over here. And let me look. 4. Okay, now I could do the same thing that I told you before. I'd put a 4 and circle it over here and a 4 and circle it on the other side of the equation. And I'm noticing that those two things matched. And then I just fill in the rest of my equation. In this instance, I don't have to because it's a 0.
Wonderful. Thank you so much.
Of course. Anytime you need help, please reach out.
Miss Taylor showed us how to think about filling in the missing numbers. When we're all done, we need to make sure we check our work. Let's say, for example, that we had a friend who thought 1 plus 3 makes 4 and put a 4 in this blank. If they go back and check their work and say, well, let me say 1 plus 3, that's 4. That's this side of the seesaw. 4 plus 1, that's 5. Wait a minute. Is this equation true or false with the 4 in there? Is this equation true or false? You tell me. This is not equal. This equation's false. So the 4 has to be wrong. Let's get rid of that. I'm so glad we just checked. If we go back to what Miss Taylor taught us, I see a 1 on this side and a 1 on this side. In order to make them balanced, I need a 3 on this side and a 3 on this side. Now they're all the same on both sides, and we use the turnaround rule. 1 plus 3 and 3 plus 1. Did you know we could even do this with symbols? We don't even need to know the numbers. Like, I don't know what a triangle, moon, star, heart mean in numbers. But we want both sides of our equation to be the same. We want this side to be the same as this side. I see a 0 over here, which we know means nothing. I kind of don't even need to think about it. But there's a star over here, so what do you think should be here? Go ahead and drag the shape you think should be here to make this really mean is the same as. If we put the star here, then we have a star on each side of the seesaw and it's balanced, so the equation is true. Basically, we just need to remember 2 ideas. You can switch the addends and still get the same answer. And anything plus 0 is itself. Yay for your super brain, especially now that it understands the turnaround rule, which is the commutative property, and the 0 property. Now it's time to get to your practice. See you tomorrow.